Have you ever thought about how some deep-sea creatures only light up when they're in trouble? I mean, it sounds like a totally backwards idea, right? Today, we're going to dive into this brilliant and frankly bizarre world where animals use light as their absolute last line of defense. Let's get into it.
Right? It's a fantastic question. When you're in danger, your first instinct is to hide, right? To go invisible. But for a whole bunch of creatures, the reaction is the complete opposite. They light up like a firework. It's a paradox that has fascinated scientists, and the answer? Well, it reveals some of nature's sneakiest survival tricks.
So there's a name for this. It's called conditional bioluminescence, and it's exactly what it sounds like. It isn't a constant, always-on glow. Think of it more like a biological light switch that only gets flipped under very specific conditions, and usually that condition is a whole lot of stress. So how does this emergency light system even work?
Before we get into the why of it all, let's just take a quick look at the how. How does an animal just create light instantly? The mechanism is actually surprisingly simple, and it is unbelievably fast.
Okay, so the basic recipe for this biological light show has two key ingredients. You've got a molecule that emits light, called luciferin, and then you have an enzyme to get the whole party started, called luciferase. You mix those two together with a little oxygen and some energy, and bam, you get light. The real secret, though, is keeping them apart until that perfect, critical moment.
So when the animal is just chilling, in a calm state, the luciferin and luciferase are tucked away in separate little compartments inside the cells. But the second that animal gets physically disturbed, it gets bumped or maybe even bitten, those tiny compartments burst open, the chemicals flood together, and voila, you get an instant flash of light.
So what's the trigger that makes this happen in literally a split second? The secret sauce is a flood of calcium ions. When the organism gets stressed, these ions rush in and act like the ultimate trigger for the reaction. This system is so sensitive, it creates an almost instantaneous defensive flash. It's incredible.
Okay, so now we know how it happens. Let's get to the really cool part, why it works. Why on earth is a sudden flash of light such a genius survival strategy? Well, this is where nature gets really, really creative.
So let's take a copod, this tiny little crustacean. Imagine you're a fish, and you're just about to have a snack. But right as you go in for the bite, your dinner flashes a blinding light right in your eyes. That sudden burst is going to startle you, right? It makes you pause, just for a moment, and that split second is all the copod needs to get away.
And this brings us to two really distinct strategies. The first one is what we just talked about, the startle effect, a simple flash to confuse the immediate threat. But the second one? Oh, the second one is way more cunning. It's called the burglar alarm effect. By lighting up, that tiny animal isn't just startling its attacker, it's sending out a massive signal that might attract an even bigger predator. It's like screaming for your bully's worst enemy to come over and deal with them for you.
But just escaping a predator isn't the only reason to have this stress glow ability. This biological superpower has been adapted for a whole range of other clever purposes, everything from sending out warnings to creating actual decoys.
We've already seen the copepod's little camera flash trick. But then you have firefly larvae, which glow when they're touched to warn predators, hey, I'm poisonous, don't eat me. Or think about dinoflagellates. That's the plankton that makes ocean waves glow. They light up when the water gets turbulent, creating this massive, spooky light show to scare predators away. And some deep-sea fish even shoot out a glowing trail to act as a decoy while they make a quick escape.
I mean, the uses are just so varied. A stress glow can be a distress signal to tell your neighbors there's danger, a clear warning of toxicity, a confusing decoy, or, get this, even a way to ward off unwanted romantic advances. It is a truly versatile biological tool. So all of this brings us back to that big evolutionary question. If glowing is so useful, why not just glow all the time? Well, the answer comes down to a really simple but really brutal cost-benefit analysis. Here's the bottom line. Making light takes a ton of energy. It is metabolically expensive. If an animal were to glow all the time, it would be burning through precious resources it needs for, everything else. And not only that, a constant light in the deep, dark ocean is basically a giant flashing neon sign that says, "Free lunch here," to every single predator in the area. And this really gets at the #1 rule of evolutionary logic. Conditional bioluminescence is the absolute perfect compromise. The animal invests in all the machinery it needs to make light, but it only flips the switch when the survival benefit is at its absolute peak.
It's the ultimate example of getting the most bang for your buck, evolution style.
When you think about it, this ability to turn pure stress into a life-saving signal is just a masterstroke of evolution. It leaves us with one last really fascinating question to ponder. If a simple touch can trigger a burst of light, what other hidden signals are out there, shaping the life and death dramas that are constantly playing out all around us, just beyond our sight?